Okay, let's have the solution to problem example 9 for the system of concurrent forces shown below. Determine the magnitude of the resultant force. Number 2, the angle that the resultant makes with the y-axis. So these are the forces in vector form. So therefore, the resultant is simply the sum of the vectors. So the x component of the resultant is simply the sum of f1x, f2x, and f3x. So substituting these values, we have rx equals 3 plus 7 plus 4, negative 6. So 3 plus 7 plus negative 6. So that would be 4 newtons. Then Ry is F1y plus F2y plus F3y. So substituting these values, Ry is equal to positive 6 minus 4 plus negative 4, then plus 14. So Ry is equal to 16 newtons. Then Rz is F1z plus F2z plus F3z, or summation forces along z. So that would be negative 10 plus 3 plus negative 8. So that would be negative 15. So R that for the resultant therefore in vector form is equal to 4i plus 16j minus 15k unit newtons. And the magnitude of the resultant is square root of 4 square plus 16 square plus negative 15 square. And it is equal to 22.29 newtons. For the angle between the resultant and the y-axis, so the y-axis is represented by its unit vector j. So we have to obtain the dot product between the resultant and j. And the result would be magnitude of r, magnitude of j, which is 1, times cosine of the angle between them, which is theta y. So r dot j equals r times 1, because the magnitude of j is 1, cosine of theta y. Substitute the value of r, which is 4i plus 16j minus 15k, that j equals 22.29, the magnitude of r, then magnitude of j times cosine theta y. And take note that I dot j is 0, k dot j is 0, so the only value that has the product that has value is j dot j, and j dot j is 1, so it is 16, then j dot j, so 16. So 16 equals 22.29 times cosine of theta y. Solving for theta y, it is inverse cosine of 16 divided by r. Take note that 16 is ry and 22.29 is r. So theta y equals 44.13 degrees. So to generalize, therefore, based on the result here, cosine of theta x should be equal to rx over r in general. Cosine of theta y is equal to ry over r. And cosine of theta z equals rz over r. So that's the general expression for the direction cosines. So cosine of theta x is x component of the resultant divided by magnitude of the resultant. Cosine theta y, y component of resultant divided by magnitude of the resultant. Cosine theta z is z component of the resultant divided by the resultant, magnitude of the resultant. So we also generalize the dot product. So a dot b is a cosine ab cosine theta. So using the components of a and the components of b, so we have axi plus ayj plus azk dot bxi plus byj plus bzk. So remember that the only product that has value is the corresponding unit vectors, product of unit vectors with another unit vector which is different from the first unit vector would be 0. So therefore, if you expand this multiplication, this is the result will be ax bx, ax times bx, I dot I, which is 1. So ax dot by, axi dot byj is 0 because I dot j is 0. So it is simple. It is just the sum of the product of corresponding components. So a dot b equals ax bx plus ay by plus az bz. So that's the result if you expand a dot b. So I hope you can remember that.